Hi guys, today we're going to talk about desertification. And this is normally the part of lecture where I'd say, what do you think a desert looks like? And I'd ask you to describe a desert to me. And, well, I can't do that. So, deserts. Deserts come in all kinds of different shapes and sizes and appearances. They can look like Tatooine with all kinds of sand dunes. They can look like scrublands like this. They might have life forms like camels and these traders traveling through them. They might have plants like these cacti that are specially adapted to live there. Some are rocky, like that part of Death Valley. And some even are covered in ice. But the thing that all of these different deserts have in common is all deserts are regions with limited precipitation. That's the definition of a desert. So it doesn't have to be sandy, it doesn't have to be rocky, it doesn't have to have cactus, it doesn't even have to be hot. It just has to have limited precipitation. We even define this as arid is basically less than 10 inches of precipitation per year, and semi-arid is 10 to 20 inches of precipitation every year. So that's our deserts. Now, deserts don't form everywhere. They form in very specific locations. And one of the places where deserts form is in polar regions, so in Arctic areas. And the reason for this has to do with the fact that cold air holds less water, less humidity than warm air. We went over that rule a long time ago, right? So cold air holds less water. Thus, in colder climates, you simply get less precipitation. And you might be thinking, then where's all that ice down in Antarctica come from? Well, when the precipitation, when the snow falls down there, it just doesn't go away. It stays there. And so that ice that you're seeing down in Antarctica has been there in many cases for a very long time. It's just been accumulating for a long time. Now, we also get deserts at 30 north and 30 south latitude. This goes back to the way the atmosphere circulates. So here at the equator is where the most of the sun's energy arrives. And so the air gets nice and hot at the equator. And that air then rises at the equator, right? That's what this is trying to show, air rising at the equator. Well, as air rises, it cools and it drops its precipitation, right? It drops whatever water's in it. And that's why at the equator we have lots of rainforests, right? Because we have this warm air rising, going higher in the atmosphere and dropping its humidity. So Amazon, Central Africa, parts of Indonesia, all rainforests. But that air, now that it's gotten high in the atmosphere and it has dropped its water and it has cooled, it's getting denser. And so this air sinks at 30 degrees north and 30 degrees south latitude. But that sinking air is very dry because as it was rising, it lost all of its moisture. So now we have this dry sinking air at 30 north and 30 south that creates many deserts at those latitudes. So here's 30 north. You can see a lot of deserts there. Here's 30 south, a lot of deserts there. But we do have deserts in other places, so there's got to be more reasons for deserts than just that. And we even sit right around 30 degrees north latitude. But we don't have a desert here because we are so close to the ocean, so close to the Gulf of Mexico, which kind of brings us a lot of humidity. All right, so other places where deserts form, in areas of rain shadow. So let's see what exactly creates rain shadow. So most of the water in Earth's atmosphere comes from the ocean. So we have the ocean here, then we have a continent, then we have a big mountain range, and then more of the continent. So what happens then is, since most of the water comes from the Earth's oceans, we get evaporation here, right? So water going into the atmosphere. And so we have this nice warm, wet air traveling this way. Well, when that warm, humid air hits the mountain, it can't go through the mountain. It is forced to rise. And when air is forced to rise, it cools, right? And when air cools, you start getting lots and lots of rain. Well, if it cooled here and dropped all its rain, by the time that air then gets over the mountain and down the other side, the air is going to be dry. And that's rain shadow. So in some places where you have big tall mountains, one side of the mountain range is going to be really wet, it's going to have lots of precipitation, and the other side of the mountain range is going to be really dry. A good example of that is in the Pacific Northwest. Over here, right, in Washington and Oregon. If you're in Portland or you're in Seattle, those places are known for the rain because they're close to the coast there. But then we have the Cascade Mountains, big, tall, 14,000-foot peaks. And that air has to go over that to the other side, and you see there's a desert on the other side. That's rain shadow. Here we can just see air being lifted a few hundred feet and it's already condensing. Now imagine it having to go thousands of feet high. We're definitely going to get condensation and we're going to get precipitation. Now, in addition to the Pacific Northwest being a place famous for rain shadow, so is Hawaii. This is part of the big island of Hawaii. And we have trade winds that come in from this direction onto the island. But we also have very tall mountains here. We have Mauna Loa and Mauna Kea there. And these are, let's see, they're 14,000 feet high? 12,000? Anyway, they're very tall mountains. And so we get this warm, humid air, and it has to rise over those big tall mountains, so it drops all of its rain on this side of the island where it's very nice and green, and this side of the island you can see is brown because it's dry, it's in the rain shadow. And there we can see kind of the edge of the green area, and we're actually getting into the browner area there. So the last place where we tend to get deserts is in continental interiors far from the ocean. And that goes back to what I was saying earlier when I said that most of the water in the atmosphere is evaporated out of the oceans. So what you then have as air masses move from the ocean on land, they're going to be dropping rain, and they're going to be dropping more rain, and by the time they get to the middle part of a big continent, they've dropped all of their precipitation, but they haven't passed over another big body of water to kind of, replenish the moisture in that air. So by the time you get to the middle of a big continent like Asia, you're going to have desert. And that's why you have things like the Gobi Desert there. Okay, so in deserts you do sometimes get sand dunes, and I just put this up here to show you sand dunes move. Notice the tree that is getting buried by the moving sand dune. And sand, as it's moving around, and especially even finer grained particles like silt and clay sized particles, can get transported great distances by wind. This is North Africa, and that's Spain and Portugal, and this is a big dust storm coming off the Sahara. Some of these dust storms can travel all the way across the Atlantic Ocean, and some of that dust can then land in the Caribbean and North America. So coming from these deserts, these dust storms can be transported many, many thousands of miles. All right, but the topic of today's lecture is not just where our deserts formed, it's what is desertification? Well, desertification is the process of fertile land becoming infertile desert. So we have land that we could grow crops in that ends up becoming something where we can't grow plants or crops in anymore. And desertification has a number of different causes. Most of them are related to poor land use, just not using the land in an appropriate way. For example, you can have overgrazing. Overgrazing is where you put too many animals on a piece of land and there's not enough plants to support those animals. That's the carrying capacity. Every acre of land can support a certain number of animals, and if you exceed that, you're going to have a detrimental effect on that land. So overgrazing is exceeding this carrying capacity of the land, and different places have different carrying capacities. Clearing the land without replanting is sometimes done. Or the growth of population centers in arid regions. When you have population centers in arid regions, those people living in those cities, they need water. And where do they get the water from? Usually groundwater. They get it from underground. And using all of that groundwater lowers the water table. And many plants in arid areas have these tap roots where they have a root that goes deep underground and can take up some of that groundwater. Well, if we lower the water table so much, if we remove so much water, the plants can no longer reach that and they will die. Similar to that, the cultivation of water-hungry crops in arid regions. This again will lower the amount of groundwater that's available and quite possibly kill many of the native plants. So one of the big things with desertification, all of these things, the overgrazing, the clearing the land, the growth of the population centers, the growing of water-hungry crops, what all of these do is they expose the soil to the harsh sunlight, right? Because all of these are kind of killing plants, right? And the plants would shade that soil. And why that's important is under the harsh sunlight, soil can get baked. It can get its characteristics changed. And so, for example, the soil might become hydrophobic. It might not absorb as much water as it once did. Or like little clay minerals can kind of bake together into very strong clumps that then, when seeds fall on that soil, they're not strong enough to take root. And so you won't get this new regrowth of plants. So that's a big thing, is when the soil gets exposed, because the plants are being removed, it changes the characteristics of the soil and can make it harder for new plants to become established. Other desertification causes are things like soil salinization, which we did talk about when we went over soil issues. So anyway, like I was saying, when soil gets baked under the sun, the characteristics permanently change. You can't just like shade them and hope they go back. And you get less water infiltrating those soils and becomes much harder for the plants to reestablish themselves. And by the way, water-hungry plants, those are plants that require a lot of water to grow, and that includes things like cotton and rice. Now, we're going to take a look at a classic example of a place that underwent desertification. And this is the ARAL Sea, and it's on the Kazakhstan-Uzbekistan border. These are former Soviet republics. And the problem with the ARAL Sea is it's basically disappearing because of poor water use. And this whole area is kind of around the sea desertified. So in 1960, the sea level, the water level in the ARAL Sea was 53 meters above sea level. In 2003, it was only 30 meters above sea level. That means the water, the surface of the water in the Aral Sea dropped 23 meters. In 2007, the lake was only 8% of its 1960 size. That means a lot of water was taken out of that Aral Sea. And during that time, the salinity increased from 10% to 23%. There used to be a robust fishing industry in the Aral Sea, but the fish all died because it got too salty for them to survive. Now, why did the Aral Sea start to disappear in this area to become a desert? It's because water from the rivers that were flowing into the Aral Sea were diverted to irrigate those water-hungry crops of rice and cotton. And so we're not having this replenishment of water into the Aral Sea, which means, you know, if you continue to take stuff away and you continue to evaporate but do not add anything to it, it's going to get smaller and smaller. Add to the issues, the lake bed sediments contain a lot of salt, which now blows onto the agricultural lands and decreases yield because it's making that soil saltier. So this is a whole bad situation all brought on because it's poor water use management in an arid area. So this is a satellite image of the Aral Sea in 2000. And we're going to see 10 years of the Aral Sea that I'm going to click through. So there's, oh, and just to show you this black line right here, that's the shoreline in 1960. That's how big the lake would have been in 1960. That's where it is in 2000. There's 2001, 2002, 2003, 2004, 5, 6, 7, 8, 9, and 2010. So you've just watched a very large lake basically disappear, and now all that's left is this little area here and a little area up there. And this is some views of the Aral Sea. This used to be the coastline. Those were some of the fishing boats. This, as far as you could see, should be water. Now we can't see any water there because that whole area has dried up. And just so you know, those aren't tiny boats, right? There's a guy walking into this boat. And, you know, that's now just sitting in the middle of a desert that once was a large lake. And you'll see camels grazing in that area now. And all of this would have been the bottom of a lake with abundant fish swimming around in there. And that brings me to the random picture of the day. And those are good students. They know to worship me. No, seriously, we were in White Sands. I'm short. I like to stand on things so I can see everybody. And when I stood on there, they decided that they were not worthy, and we thought it was really funny. So anyway, that's Desertification. I'll see you next time.